Hello, my name is Ashwin, and today I'll be walking you through describing transformations. Now, before we get into the problems, let me go through some of the translations. So the first one we have here is vertical translations, and so some examples we have are f of x equals x squared plus 2, and f of x equals x squared minus 2. Now, the graph of f of x equals x squared plus 2 would have the parent function x squared move up 2 units on the graph, while f of x equals x squared minus 2 would move it down 2 units. Now, let me bring you over to Desmos, which is an online graphing calculator. So we have the parent function f of x equals x squared. And now let me show you what x squared plus 2 would look like. So as you can see here, it goes up 2 units on the graph. And then now you can see x squared minus 2. You can see that it moves down 2 units on the graph. So the next thing we have is vertical stretch or shrink. You have f of x equals x squared times 2, and f of x equals x squared times 1/2. Now, when I show you the graph of this, you have x squared, and then you have 2x squared, which kind of makes the graph seem a bit more shrinked. And then you have f of x equals 1/4 times x squared, which would make it more stretched. Now, to have a vertical shrink, the x value, or like this value right there, would have to be greater than 0 and less than 1, while a stretch would have to be greater than 1. Next thing we have here is horizontal translations. So f of x, as we're shown here, f of x is equal to x plus 2 squared, and we have f of x equals x minus 2 squared. So once again, we have x squared. Now let me show you f of x equals x plus 2 squared. You can see that it moves 2 units to the left. And then you have f of x minus or equals x minus 2 squared, and you have that the graph has moved 2 units to the right. Now, a lot of people usually confuse this, and so I'm telling you now so that you don't confuse it later. Because you have an plus 2 here does not mean that it is going to move to positive 2 on the graph. The original equation, I'll just type it, I'll just annotate it right here, is kind of like x minus k. And so the k value would already start off as a negative. So when you have -2, like moving left 2 units, it would be plus 2. Let me just erase this. So when you replace it, you would get minus or plus 2. And then you know how it's the opposite for x minus 2. And then you've got horizontal stretch and shrink. You've got f of x equals 2x squared. 2x is in brackets, and f of x equals half of x in brackets squared. Now let me show you the graph of this. As you can see, the 2x within the exponent is kind of more stretched than the x squared. And then you've got 1/2 x squared, and it's a bit more stretched than the original graph f of x equals x squared. Now let's get into the problems. The first problem we are given here is 2x squared minus 4. So based on what we've learned, we know that minus 4 would equal down 4, and that this right here, the 2, would be a vertical stretch by 2. So we can just graph this. So we had 2x squared minus 4. And as you can see here, you've got the graph of x squared, and you're moving it down 4 while having a vertical stretch. So if you didn't move it down 4, you can see that it kind of like has showed that vertical stretch. And then the next problem is g of x equals -3, x plus 2 squared plus 3. So what we learned from our horizontal translations is that this is actually moving, the original graph is moving left 2. It has, there's 2 ways to say this. You can say that there's a vertical stretch by 3, by a factor of 3. And you can say that there is a reflection over the x-axis. And let's not forget that the graph is going up 3. So once again, we'll just graph this. So we got negative 3x plus 2 squared and plus 3. So as you can see here, let me just solve this. So as you can see here, the graph has moved left 2. We've gone up 3. We reflected across the x-axis, and we've also got a vertical stretch by 3. So what I think what I should do here is like an easier step-by-step. So we've got x squared, and then we got that horizontal translation plus 2. Got, so that, as you can see, it moved left 2 plus 3. It's gone up 3. And then we had a vertical shrink, you can also say, of negative 3, which is moved right there. And for our last question, we've got negative 2x squared minus 2. So we know that the negative would be a reflection across the x-axis. I think it would be easier if I just wrote it in text. So reflection across the x-axis. We also know that the graph is going down 2 units and that there is a horizontal stretch, by 2 units, or by a factor of 2. So once again, we'll just graph this. Right. So we can see that the graph is down here. You've got original graph f of x equals x squared. And then you've got the vertical translation down 2, got the vertical stretch, or the horizontal stretch by 2, and a reflection across the x-axis. So once again, I'll just do this step by step. So we've got down 2, we've got a horizontal stretch, and then you've got a reflection. That's what the graph looks like.